Today we're going to be talking about the inverse of a function. So first of all, what is an inverse? So essentially an inverse undoes the action of a function. So for example, if you have a function like y equals 2x, that is doubling the values of x. So its inverse would therefore be halving the values of x. Another example is the square root. The opposite of squaring or square rooting is squaring. So those would be another example of inverses. If you want to figure out graphically an inverse, you can reflect it across the line y equals x, which you can see in this Desmos example here. Algebraically, if you want to figure out the equation of the inverse, you can let y equal x. So you would switch them. If a function passes the horizontal line test, which, as you can imagine, is like the vertical line test, except horizontal, that tells you that the inverse will be a function. If the inverse is a function, it's called invertible. A common mistake is that people think the word invertible means that the inverse exists, but that's not true. Invertible means the inverse is a function. The inverse of anything exists. Here you could find the inverse of a smiley face by reflecting it across the line y equals x. So you can find the inverse of absolutely anything, which is why the word invertible actually means that the inverse is a function. Looking at this example here, just keep in mind the notation. This little exponent kind of -1 means inverse. So here we want to find f inverse at 8, which means you want to find the x value when y is 8. So instead of, in the first example, x being 1 and y being 2, in this example, y is 8 and x is 3, which you can see graphically. Now, in advanced functions, you would have learned, or sorry, in functions rather, you would have learned this method here, where if you want to find the inverse, you would switch the two variables. Now, when there's context, that's actually not the correct way of doing it, because, for example, here this is saying circumference is 2 times pi times the radius. So if you were to switch them, then you're saying the radius is 2 times pi times the circumference, which is just a false statement. So if there's context, you should not use method 1. If it's just x and y, absolutely use method 1. But if there's context, please use method 2. Method 2 is actually even simpler than method 1, because method 2, you don't have to switch variables at all. You just have to isolate for the other variable. So originally, c is isolated. So to find its inverse, we need to isolate for r. In terms of notation, we're going to use the -1 to denote that it is an inverse. The only other difference is that now our variable, our input variable, is c, not r. Okay, again, for question number 3, it's asking us for f inverse at 4. So there's two ways of doing that. You could first find the inverse equation and then sub in 4. Keep in mind that if you are undoing a square, you should add a plus or minus. In this particular case, it's the radius, and radius is always positive, so we actually don't need the minus version of that. So this is one option of finding the inverse and then subbing in 4. Method 2 is actually more efficient. That involves simply letting the volume equal 4 and isolating for r. Either way, you get the same answer. You can see one is just a bit quicker than the other. For our last question, here it's kind of getting at the fact that if you apply a function to its inverse, in essence, they cancel out, because this is performing the operation and this one is undoing the operation. So if you apply those to each other, then really just this input is what's left over. So here we kind of showed it the long way around. but that's kind of a rule that you can use in general. Okay, thanks for watching.